At some point in time, your client is coming to you and saying that, you know what, I don't need this line, or I don't need a set of lines. It can be one line, it can be 1,000 lines also. Maybe that line is not compatible with your code. What you can do is go to the history, understand that, okay, fine, this test line is coming from a test branch which was committed using a pull request, and then you can revert the pull request back. So you can undo the changes very easily without having to go ahead and edit your file. You say revert, and now it's telling, okay, fine, how do you want to revert it? You are trying to revert the pull request name. Reverting the changes in this pull request into the target, a topic will be created. Meaning it's telling, if you want to revert a change, I will create a new branch. It's telling test branch revert from main. I'll say revert, and it's telling there are a lot of conflicts basically that I encountered and etc. Because I've edited the file a lot of times, so there will be a lot of conflicts basically that you know kind of get out there. And also the source branch was deleted. So let's say revert encountered conflicts. Well, this one the operation needs to be performed locally. We'll talk about what are conflicts and etc. will become there. But this branch right now cannot be reverted directly from the cloud. For example, let's say you do a new change, and this change is something like this. Say it. I'll say testing a change revert. I'll say this is a revert test. Same commit out here. Then creating a pull request. Then going into main. This is from test branch into main. So I'll say this is test change. I'll create this out here. I'll say complete it. I'll say complete the merge. So now if you look at your main branch, again it is merging the pull request. You'll have to wait till this does. It'll take about 10 or 15 seconds to this to be happening. If you now look at your branches, now go into your main branch out here, go into the history. I now have a test change that is coming in, and this test change basically said, let's say testing a change and all that stuff. If I want to revert this, I will be easily able to revert it because I now have a pull request called 111 that is created, and I can now say revert and click on this option called revert out here. Now what it does is that it created a new branch called test change revert from main. Look at the files, just taking around these two lines out of your file out there as such, because 111 changed these two things out. So it's now telling I will want to, let's say, take these two things out there, and it'll go ahead and revert it back. So if I just go ahead and say create and just say complete, the changes are reverted. But if you do a direct merge, if I come into the main branch, all these things that don't have a pull request ID with them are direct merges out there. A direct merge, I cannot go ahead and undo it. It's very difficult to undo a direct merge. I'll have to create a local copy, understand what are all the changes, delete those changes, and recommit it back again. Resolve all the issues and recommit it back again. Reason being, organizations will always and always tell you to go or to come via a pull request. They are going to request you to come via a pull request, and now they are going to tell you that there are no direct commits allowed onto your main branch. We'll see how they enforce those policies and all these things out. But yes, any questions still here? Anyone, any questions still here that I can take?
Without revert, we can't delete the line.
I'm sorry, can you come again, please?
Without revert, we can't delete that
Mhm.
line.
Without revert, can you not delete that line? You can delete that line. You can identify which line it is, remove it, recommit it. Not going to cause an issue, but this is just a simple file. What if there are thousands of lines out here and all the lines are not in a serial order? They are randomly placed. You want to remove all of them. Now imagine how difficult it's going to be for you to, let's say, go ahead into each and every line, understand where it is, remove it and all that stuff, and then recommit it. Instead of doing that, just go ahead, revert the pull request back. That's it. In that pull request, exactly. It will be reverted back. So only the content which went inside, they won't be affected. No. they won't be affected. Only the content is added with that pull request will be reverted back again. Again, if you look at the history, there is a revert change also with another pull request. Even reverts are done with a pull request so that you can redo the same thing. If you want to apply them again, you can take this pull request and again revert it back. It will apply those changes back again out there as such. So each and every pull request will have its own number. You can revert a pull request. That's the reason it's always suggested to come and commit changes using a pull request, not a direct change out there. Direct changes are not entertained, not encouraged at all. Yes, it will create a new pull request. It will create a new branch and create a new pull request out there. So if you look at this branching structure right now, I had main, I had test. This branch got created when I created a revert. So it created a new branch. It understood what are all the changes that I need to do in this particular branch. So whatever you did manually, Git is doing that for you automatically out here. You do not have to, let's say, come here manually, do a lot of things out here. Git is automatically doing that. You just have to, let's say, approve that particular pull request out there as such. Yes. Any more questions here?
Hello.
In real time? In real time, what will be the branches? You'll have a main or a master branch. You'll have a develop branch. You'll have a feature branch. You'll have a hotfix branch. You'll have a release branch. In order to understand what they are, we'll have to do one more concept called branching and merging strategies. So in real time, to help you understand why do you need a main, why do you need a develop, why do you need a release, why do you need a hotfix, we'll have to do a concept called branching and merging strategies. Then that will make a sort of sense for you, which we will do, which we will do, understand what are branching and merging strategies out there. Yes. Any more questions here? One more thing is that can I do all these operations from my local machine? Meaning, I want to go ahead and clone firstly my main branch. So I'll do that. I will say clone, and once clone, I'll say clone VS Code. I'll say open the VS Code. As and when I open this VS Code, it's telling, do you want to open this extension? I'll say okay, open this out, not a problem. I'll select a folder. I'll say select repository location, and I'm just cloning this out here. Clone this out. You have, this is a test, this is, let's say, the new the test branch and all that stuff. I want to add a line. If I am adding a line, can anyone tell me which branch I'm adding a line on? Main branch. How do you know it's a main branch? I'm sorry, we clone from main branch. But can you, using this VS Code, can you tell me which branch it is if you do not know that? No. Yes, exactly, yes. In the left hand bottom corner, it will tell you which branch you are working on. It will tell you which is your parent branch that you're working on right now. What I can do using VS Code is that I can go here, click on this branch, and now I can say create a new branch from. I'll say local branch. I'll say enter. It's now asking me which branch you want to, let's say, take as your parent branch. I'll say main branch. And now do you see I'm working on what? A local branch out here as such. This operation of changing one branch to the other, meaning I was earlier working with a branch called main. I changed this to a local branch. This operation is called checkout. Git checkout. Very simple. Git checkout is nothing but changing a branch. That's it. Changing the branch that you're working on is called checkout. What I can do right now is I can now go ahead and add one more line telling this is a sample line from the local branch. I can do that. Save this changes. As and when I save this changes, it will say that there is one change. Stage this changes. I can add a message telling this is a local commit. Commit this changes out, and then click on publish the branch. The commits that I did till now are on my local machine. are on the local branch that is there on my local machine. If I hit publish branch, what this is going to do is that it's simply going to go ahead and create a new branch out there in your repository called what? Local branch out here. What you can do is that optionally, if you want to go ahead, merge your changes from local branch into your main branch, you can come here, create a pull request. That's something that you can, let's say, anytime do. But you can also go into your VS Code, change the branch to, let's say, main, click on these three dots. Now I'm checking out to main. Say, click on these three dots. I'll say branch, merge branch. And I can say it's telling select a branch to merge from, say, local branch out here. Then sync the changes back again. And once I sync the changes back again and do a refresh, go here, sample lines from the local branch, look at the history. This is a local commit out here. This is how I did a merge using a local. So again, if I come here, click on branch, say create a new branch, you can create a local branch out here. After you make changes, you can publish the branch. Safest way to do a commit is pull request. Just go with a pull request and let's say do a commit. But you can optionally go ahead and merge your changes. You can just click on this one and you can say, let's say branches, and you can say merge the branch out here as such out there. Yes. Any questions still here that I can take? Anyone? Any questions that I can take? If we clone the main branch automatically, yes. If you clone the repository, automatically all your branches will get reflected out there. One final thing that I want to, let's say, tell you is that let's do one thing. This is the, let's say, main out here. I go here, click here. I'll say this is a change. I'm adding some lines out here. I'm telling this is a change on Azure Devops. The capability of Git is that Git will allow you to work offline, meaning you do not have to, let's say you are on a flight, you need to work on some code, you're a developer, you can simply carry your system without having to connect to the internet. You can start working on your local system and do a lot of commits and do a lot of things out here. But the downside of that is that, let's say you're doing some change out there in your local machine. So one of your team members is also coming here and making some change on Azure DevOps directly. So there are two parallel changes that are happening. Let's say commit. Let's say this is a parallel change. So someone already did while you are working on the same old copy out here. You are having an old copy, but the, let's say, the remote repository is updated with a new copy out here. Now, before, in order to avoid something called as conflicts, we call them as merge conflicts out here. The reason you get merge conflicts is that you will have multiple team members working together. You do not have a control on what team member does what. In order to avoid merge conflict, it's very important. Click on these three options. Say pull. Do something known as a git pull operation out here. What does a pull do? Is that, do you see what happened right now? When you did a git pull, Git automatically connected to the remote repository, understood if there are any changes, pulled all those changes into your local machine, and then said, okay, fine, these are all the changes. Now go ahead, do what you want to do. So now using this particular git pull operation, out here, I will be able to make sure to sync my local repository with the remote repository always. My local should always be in sync with my remote repository so that you don't have any conflicts as such out there as such. Yes, any questions still here? Anyone, any questions still here? Normally, if you are offline for a long time, And if you are doing some changes out there, just to be on a safe side, you do a git pull. You can do a pull out there. It's not a pull request, it's a pull. Pull request is different, git pull is different. Pull will just go and take all the changes, sync it to your local machine out here. So before you do anything, just do a pull. That'd be good enough. Yes, let's take a couple of questions. Should we create a new branch for every major change that we make? Even for any minor change, even if you are editing a comma, do a pull request. Pull request is the suggested, let's say, way. All the versions are being maintained by developers or we have to intervene from DevOps side. Depends upon whether it's a code or whether it's an ARM template or a Terraform script or let's say something like a PowerShell script out here. If it's a Terraform, you have to intervene. If it's in, let's say, code, you do not have to, let's say, intervene out here. What would happen if you mistakenly commit without staging the changes? It will automatically stage all your changes. So if you do not stage your change and by mistakenly you commit this out, it'll just give you a warning telling that, do you want to stage all the changes? Just say yes, it will stage all the changes and then make you ready for the commit. All the versions are being maintained. Okay, I've answered this already. So yes. Yes, any more questions here? Who will approve the pull request? Good question. Normally, a pull request is approved by a technical lead. Technical lead, because what they do is that before approving their pull request, they'll see what are all the changes that are coming into a pull request, understand how the changes are coming to a pull request, and then approve it out to maintain the code quality and a lot of reasons out there as such. Any more questions? Correct. Why do we do it in a VS Code is because on Azure DevOps, it's a little difficult to do the same process. It's again, you have to understand this is just one file. What if you have hundreds of files that you want to commit to, that you want to change? So in that case, what will happen is that you'll have to edit one file, commit it out, then go to a different file, edit, commit it, then go to again. If you forget that, okay, fine, I'll have to, let's say, do some commit on the first file. You'll have to come again, edit it, commit it, do a pull request and all that stuff. Instead of which, it's easy for me to go ahead, make all the changes at once in my local machine, commit them out in one commit, and push them out back again. So it's easier to operate on Git on a local system rather than on a remote repository directly. Security, yes. Meaning, when you talk about security, both your local and the remote repository, whenever they talk to each other, they talk over an encrypted channel. It's a TLS session that gets established, a transport layer security session that gets established. So yes, it's an end-to-end encryption that happens out there. So you do not really have to worry about that. Yes. Any more questions out here? Good question. Is there any way no one can make direct changes onto main branch? They should not basically go ahead and say direct changes onto main branch. You can send out an email to your entire team telling don't make a direct change out there. Is that an efficient way? Do you think? That's the reason you have something called as a branch policy. If you go to a main branch, click on these three dots, just scroll down, something called branch policies out here. If you put a branch policy, for example, let me put a simple branch policy telling that I at least need one person to review the change before you commit it. I'll say switch this on. I'll say I need minimum number of reviewers as one. I need at least one reviewer before you commit your change and leave this. Okay. Come back. Just you see beside your main branch, you have a badge right now. Just now telling branch has what? Policies. It's now telling branch has policies. So what's going to happen is this. If I go into a branch that has policies, say this is a sample change. Error. Pushes to this branch are not permitted because the branch has policies out here. This is how you restrict someone by doing or from doing a direct commit. Same thing happens on your local machine as well. If I go here, I'm working on the main branch. This sample change, save this out. You can commit changes onto your local machine. That is not an issue. I'll say change and all that stuff. I'll say sample, commit this out. But I cannot sync the changes back again. I cannot push the changes back again. I'll say okay. And let's see what happens. uh, can't push the reference to remote. Just open the git log out here. Do you get the same error message what I get in Azure DevOps? Pushes to this branch are not permitted. You must use a pull request to update the branch out here. Same thing. So pushes are not allowed. This is how you control how someone commits this one. Now your developer has no other option. They will have to come with a pull request only. That's how we force them to go through a pull request and not a direct commit out here. This is the way in order to, let's say, by enforcing something called as branch policies, which will, let's say, explore more on what a branch policies is, what does it do, what will it do, what are the number of branches, how do we, let's say, go and configure all these things out. Again, creating a repository, creating a branch, implementing a branch policy. These are the duties of a DevOps engineer till here. We create all these things, we maintain all these things, we put the policies out there, we also maintain the security of this one. We'll also talk about all those things as such. Yes, any questions still here? Anyone, any questions still here? Mhm. When you say, sorry, can you come again? Comparing the changes side by side. So when you do a commit, let's see if I have something like that I can show you. Since I've committed this already, I won't be able to see this. Let's see. Given source repository is something. Let's see changes. State of changes full something like this. Let's see sync remote branch, merge branch, lead branch, compare branch. I should have something like a compare, but if I don't have that, let me do one thing. I have to, let's say, check that out before I commit it out. I say test change, save this out, and you get this. You click on this, you can have a compare. You can have a comparison between what is coming in and all these things. There's also a way you can check the entire history, but you'll have to run a command telling git history or git branch history to see what are the history basically that I have. Yes, any more questions here, guys? Hmm. Will they have their own branch? Will they work on a single branch? We'll talk about that. We'll talk about that in the branching and merging strategies to make much more sense into that. Uh, do repos have something like access management? Who can create a branch? Who can approve the pull request and all these things? Good question. Do repositories have access management? I would rather say, does Azure DevOps has an access management? Yes, Azure DevOps has an access management, which we will talk about on how to add a user, what kind of an access he gets, and what kind of a permission that you can give to one particular user out there, and so on and so forth, which we'll talk about in the coming session on branching and merging strategy out there. I'm sorry? No, it's not under the RBAC. RBAC is something that you do on the Azure portal. But if you come into Azure DevOps, let's say leave, you have something called Azure DevOps. There's something called organization settings. If you go here, you have users. You can add multiple users in here. You can say the name of the user, something like xyz@gmail.com. Level of access, you can say it's a basic stakeholder Visual Studio. It's the licenses that a user gets out here. I'll say basic. And I can add a user to one of the projects that is available in my organization. Let's say DevOps learning. And now I can say whether he's a reader, contributor, or an administrator out here. Administrator, create, delete, whatever they can do, put in branch policies and etc. but contributors and etc. have a limited right. For example, if you want to see that, let's go into permissions, and here you have something known as contributors and all these things. So let's see that. So you have administrators and etc. Let's go into a project, say DevOps learning, and here you have project settings. If you go in here, you'll have permissions, you'll have contributors. Now you can see what a contributor does. Can he delete something? Can he create something? Can he maintain the repositories, manage project repositories? Can he do that? If you say do not allow it, then they won't be able to create repositories and all these things out here. We'll talk about again this one. This is something which is a user management, which I need to cover along with branching and merging strategies, but just giving you an overview on how this happens out there. Is any more questions, guys? All right, thank you guys, and have a good day. We'll meet tomorrow. We'll discuss more on branching and merging strategy. Please come on time to tomorrow's session. It's going to be a very important session tomorrow for branching and merging strategies, depending upon which your entire Azure DevOps foundation will be laid. Okay, thank you.